Faces live coverage from Austin, Texas at the tech gathering of the year. You know, the place where Twitter found its wings, Foursquare checked in, and Siri found her voice. It's Robert Scoble and Friends, live.
The Open Cloud Experience.
This is Robert Scoble. Welcome to the Open Cloud Experience here at Rackspace, Rackspace's space at South by Southwest in Austin. Today I have something special. I have a 17-year-old who could put Rackspace out of business in a few years. And that might sound scary as a Rackspace employee, but this is how the world works. Somebody comes up with an interesting new idea and disrupts the world, and we better keep on top of it or he'll end up being my boss soon. And so I'm really honored to have Thomas Sohmers. I found him walking around here, and he started showing me all sorts of stuff he's built already as a 17-year-old, and it was just amazing, and I had to have him on. So who are you?
So I'm Thomas Sohmers. I'm a junior right now in high school, but I've been working at MIT for the past 3 years on a variety of different things, everything from augmented reality to embedded cluster computing, which I'm showing here today.
Yeah, we could spend hours talking through what you're already seeing. What is this thing that you brought me here?
So this is a cluster of 11 based development boards made by Texas Instruments using the OMAP 4460 processor that's probably best known for powering the Galaxy Nexus and Droid Razr smartphones. But in this case, we have just the development board without any of the fancy cell phone equipment, and just using the raw power from them and running Ubuntu to be able to unlock the real potential of these processors.
And why did you build this? What did you want to do with it?
Well, I am a geek.
Are you going to run OpenStack on here and build a cloud data center here?
Well, yeah, that is one of the goals. But really, being a geek, the original intention was just to see if it could be done. And cluster computing using off-the-shelf equipment has been done for a while. Originally, back in the early 2000s, late 90s, it was called Beowulf cluster computers, where you just took off-the-shelf desktop PCs and chained them together with special software to be able to do functions of much better PCs. But now, very good processors, x86 processors are fairly cheap, so people don't do that anymore. But really the new field is taking these very power efficient processors that are within smartphones and tablets and using those instead for much different goals, such as servers and mainframes and even supercomputers.
So I've seen lots of companies who are trying to use ARM processors in the data center. That's these low power processors. For instance, I interviewed SeaMicro's CEO a few years ago. He's since sold the company to AMD, I believe. But SeaMicro had a board like this that used an ARM processor, and he claimed it used about 10% of the electricity of Intel motherboard that the data centers mostly run today, including Rackspace is mostly an Intel shop. What's the properties of these boards compared to what Google or Facebook or Rackspace run?
Well, it's just like SeaMicro. It did use they do use ARM processors, and ARM was originally based off RISC systems back in the 80s and 90s, and so but it's evolved now to be just a processor for very low power devices like smartphones and tablets. But what I really think is going to happen in the next 3 to 5 years is people are going to start accepting these devices as really being the replacement for conventional x86 processors used by AMD and Intel. The actual differences in the architecture itself, they're not binary compatible, so if you write an application for an x86 machine, it will not run on an ARM machine without recompiling it.
And that's one reason why Rackspace has resisted ARM so far, because we have so many different customers and our cloud needs to run a lot of workloads that are x86 based.
So what's really awesome now is since ARM processors are becoming a lot cheaper and a lot more prevalent in the industry, both as phones and in other places, is that it's now really easy to recompile things for ARM. So GCC has native support, LVM and Clang just added support for it, and makes it so that application developers can easily port their existing code base and their libraries and everything else to the platform. On all 11 of these boards, we're running Ubuntu 12.10 currently, running the Linux 3.4 kernel, but I do have 3.8 working. Not that stable, but working on that. But really, These Panda boards are about 2 years old. It's not that great of the newest technology. So really, what I'm starting to work on now is some new ARM development boards, and this is just kind of what I have.
And you showed me an ARM chip yesterday. In fact, I think you're holding it there.
Yeah.
Oh yeah, let me get you into the GoPro here. And
I'll take that
that's
out.
Rocky, by the way, behind the controls on his new TriCaster.
Yeah, so this is a new board we're working with, and so don't know how well you can see that, but
Yeah, you can see it pretty good.
this compared to the OMAP 4460 that is on the Panda boards, which is the OMAP is dual core 1.2 gigahertz and a gigabyte of RAM. This little piece here, which I guess you can compare to how large it is compared to these Panda boards. This here is quad core, 2 gigahertz per core, and has 2 gigabytes of DDR2 RAM. So this very low tiny piece, which is about a quarter by a quarter, or 2 quarters.
Yep.
It's extremely small, and the kind of idea when it comes to servers with these is that you can fit between 50 to 75 of these in a standard 2U rack. And by putting these together and using some of the new techniques that I've been developing for connecting these in board, you can daisy chain these to do much more powerful applications at very low wattage. Each board uses about 3 watts of electricity, and so a 50 board unit should use between 150 and 200 watts.
So this is really important for the data center world, because as electricity usage goes down and power and performance goes up, we can do new kinds of things in the cloud. We can keep up with huge amounts of data feeds. I mean, one of the trends here at this South by Southwest is all these sensors coming out, either on watches or cars. Soon we're going to have self-driving cars that are just going to suck up huge amounts of data and need to shove that somewhere, process it, and then shove it back down. We need new kinds of data centers to deal with this, right?
Yeah, and one of the other big things when it comes to power and overall use is you can touch this if you want.
Yeah.
Feel
It's
free.
cool.
It's completely cool to the touch. We do not need cooling for this type of system. So
And
there's
this
11
is another
boards.
trend we're seeing in data centers. It used to be you had to keep the data center very cold, maybe about 65, 70 degrees. Now we're seeing data centers that run upwards of 90 degrees, right?
Mm-hmm.
Which means we don't need to spend electricity to cool the air in the data center. These run very, very cool and can be air cooled with normal ambient temperature, even in a hot place like Texas, right?
Yeah, and so I have here kind of a little photo of the work we were doing this summer. And so basically what we had here was a Panda board trash can. And so we just took a Rubbermaid trash can and had 48 Panda boards compared to the 11 I'm showing here, and put those in a giant cluster with a very large network switch. And the really awesome part was that we were powering this entire thing off a solar panel.
Wow.
And that was kind of just to show, kind of a gimmicky way, I guess, but to show that how power efficient this was. So this Panda board cluster, which Panda boards honestly aren't that powerful. They are 2 years old, and ARM has come a long way since then. And so those processors in there were able to compete against a full server solution at a sub 250 watts. It had a max peak of about 260 watts.
Wow.
So
Cool. So, what can you, now that you built this, what, you have a computer, in fact, this is a Chromebook, right?
yeah, so I'm running a Chromebook right now. So I'm just using this because it's very thin and light, and I can still access this. So I just have a USB Ethernet adapter, so I can go right into this network switch. Normally when I'm at the lab, this is all internet connected, so I can just wirelessly SSH into it. But I've SSH'd into the Panda
For
board.
normal people, I know
Okay,
what SSH
yeah.
means. What is SSH?
So SSH stands for Secure Shell, and basically it allows you to remotely connect to a network very easily. And so, or not connect to a network, but connect to another computer. So it typically uses some form of authentication, a password, RSA key, etc. And in this case, I'm connected directly to one of these boards. And so this one's named Panda 25, and Panda 25 is the designated host for this.
That's this board right here.
It's actually this one down here.
All right.
But Panda 25 is our host, and you can see it nice blinking right there.
It's this board here?
Yep.
All right.
So Panda 25 is running a Apache server on there right now, which is now spewing out some data for us to view the performance and other things from here. So you can see we have this web monitor here. Can make that. So currently we have only 7 of the boards currently up and 14 CPUs total. And you can move over here and you can see some nice graphs representing what's going on. I can then go into like the physical view where you can see each node.
Okay.
Takes a second to load. But the whole idea is that you're able to output information to a other computer. So you can see each one of the nodes listed here, and then over here you can see total CPUs, how much memory, RAM it has, disk space, and you can get a lot more metrics. This is just a really basic setup to just show basic concept, but we can flesh this out to full control of the system through a web interface,
Very cool.
making it a lot easier for system admins.
So now what can you do by talking to this board? What would you be doing in your lab?
So we've been using OpenMPI to be able to do a lot of benchmarking and other things. We can daisy chain them together and be able to do any sort of scientific calculations, benchmarks, etc. When we were doing this past summer, we had it just calculating pi for about 3 days, just to be able to kind of gauge what the total power usage is when it's at full capacity. And yeah, we did pretty well. But the real idea is we're trying to get away from this sort of setup and instead to direct connections, because how all these are connected right now is it has a mini USB connecting to each one of these, which is providing power, and it has just gigabit Ethernet connecting it to a switch to do everything. But the idea was with these small ARM boards, which would be put inside a standard server rack, you'd be able to do up to 10 gigabits per second interconnect between these, meaning that it's faster than the RAM, which is about 5 gigabits per second. So that you can do some really, really fast computational work in between them. And it would be like it was just one continuous system.
So while you're innovating here, and this is the future of the data center, I just met Skyera, who's innovating in storage. They're building things that look like pizza boxes, 2U or 1U server box that has all SSD, very, very fast storage to store to that. Are you excited about the innovations elsewhere that these processors are going to be able to do things with?
Yeah, I'm excited about innovation anywhere, and the whole idea is if we can fit 50 of these in a 2U rack, you still have an entire, anywhere between 8 to 12 other slots to be able to put other stuff in. So you can maybe have 5 of our systems in there where you have 50 times 5 of those. So 250 CPU, or not CPU boards, but of these boards in there, plus you can have any amount of storage you need. I'm currently working on trying to get SATA working through this. It's not as easy as it would seem. So we're currently relying on eMMC, which Samsung provides. It's not as good as full 3 gig or 6 gigabit SATA connection, but it's good enough for what we're doing right now.
So I've heard you speaking with lots of interesting people here, and I've seen a few people offer you jobs here. And somebody in fact gave me heck for not offering you a job, and I'm like, no, I'm going to take you to see Steve Jurvetson or somebody like that, or Mark Andreessen, and let's start a company. Is that what you're thinking of doing with your career? Because you obviously are at the place where you're going to be able to build stuff and innovate and do something that even a big company like Rackspace can't do.
Yeah, well, I think I have that entrepreneurial spirit, and I really like creating new things, whether that's a cluster or any sort of new technology, including a business. And I really think that there's great potential in these sort of processors being used, not only in phones and servers in the next 3 to 5 years, but I think that this is going to eclipse Intel's, and well, not just Intel, but any x86 system in personal computers as well. And I really believe that in 10, 15 years, instead of all of us having MacBooks and all these other fairly powerful machines in our laps. We'll instead have these thin clients which have the most basic hardware in there, and instead we connect to these things in the cloud. And since it's very low power, it's not being a huge tax load on the world as a whole.
Yep. I should turn off my phone, speaking of my phone. That's an interesting, in my career in the computer industry, I've seen this swing back and forth between thin clients and thick clients. You know, the MacBook is a fairly thick client. My next door neighbor works on the Google Chrome team, and he showed me the new Pixel Chromebook, which is pretty cool. You want one? I probably could get you one.
Oh, well.
They're pretty nice. They're $1,700. They have a beautiful screen. You touch the screen and scroll up and down and do all that. Do you think thin clients are really going to be the way the world goes, or do you think we're going to see another swing back to where we run heavyweight software again on our local machines, whether they're smartphones or whatnot?
So I'm from Massachusetts, so I've been there my whole life, and I know a lot of other people there, obviously. And I'm not sure if you remember, but DEC, Digital Equipment Corp, back in the 80s, and even though I wasn't alive to see that, I've heard a lot of stories of them, and really interesting thing, and one of my kind of heroes of the technology world is Ken Olsen, CEO and founder of DEC, and he's really interesting, and it's sad that he's kind of the only thing he's remembered for now is saying that I forget the exact quote, but basically it was like nobody would ever want a personal computer. They shouldn't have to have a personal computer.
I think you said that we don't need more than a few computers in the world, right?
Yeah, and
we at Microsoft in their company store, they run his quote to sort of make fun of people who can't properly predict the future, which I don't try to predict too much.
But I think he actually did predict the future in a way, in that, because he was actually misquoted. There was a much longer version of that quote where he continued to say that he didn't think that there should be a full computer at every desk. He thought that there should be a client where you would then connect to a remote server where all of your files and everything else would be hosted. So he was saying this around 1985, or just after the first Macintosh came out. And it was really, looking back at it, we have the cloud now, and I have this thin client, which even though it does have a real processor, it could do real work, I actually run Ubuntu on this machine as well, on top of Chrome OS. But I think that we could go back to that sort of model where everything is up in the cloud, everything, even if that's Rackspace or any other server company, or if you have a cloud at home. I mean, this sort of system is cheap enough that anyone could really afford to have a personal cloud at their home where any of their devices can connect to. And it would be cheap enough, it would be small enough that I think it would be really valuable. And I think Ken Olsen was ahead of his time in thinking that. And we kind of had to go through the whole PC swing to go from these huge personal computers going to these really, really thin and small ones we've been seeing over the past 2 or 3 years, and now we're eventually going to kind of get rid of them.
So what's your family like? You know, what do your parents think of you getting into this? Were they programmers too, or technical people?
Well, my mom, she worked in Boston when I was really little, and I owe a lot to my mom. And so she worked in desktop publishing. She set up newspapers and stuff. She didn't do any programming or anything, basically just doing layout and things. And so I used to go into Boston with her every day when I was born to when I was 5 years old or so. And so I went into Boston. I got to so obviously she worked in an office with computers and everything else there, and so at a very young age I had access to a computer, which probably if I didn't I wouldn't be how I am, but just having access to that I think really sparked me. And even though I was just into playing games when I was very, very young, as I got older I kind of developed more into how to create things, and I really liked building, and I kind of have to thank my dad for that. I mean, my dad's kind of a celebrity. He was an appraiser on Antiques Roadshow. Yep. He does collectibles and stuff like that, so he's not in technology
I didn't even put
business.
the two names together, but I watch Antiques Roadshow all the time.
Okay, cool.
That's on our
Yeah, he's flowered shirts, Hawaiian shirts and that stuff. Yeah, so my dad's into that, and but he obviously deals with a lot of toys and collectibles and that sort of stuff, so I grew up with that too. And the thing I think I played the second most with, besides computers, was Legos. And I absolutely loved and still love Legos, because just that ability to be able to take all these different things, to be able to put them together and build, I think really solidified kind of my engineering spirit. And I really love building stuff. Just to think that with a computer, either when you're programming or with now with CAD software or with any sort of like Eagle CAD or anything else that allows you to build circuit boards, you can create something entirely new. That we now have the ability where anyone can take up a book or take a class and learn fairly easily how to think completely different and be able to genuinely add value to the world. And I think that's amazing, and I really want to continue doing that.
Well, we can't wait to watch your career and see what you do next, because you're playing in an interesting space. It feels, you know, Steve Wozniak walked me through the Computer History Museum and talked about his childhood and where the steps along his career to building the Apple I, and I feel like I'm watching, someone on the same kind of path. So. Can't wait to see what you do next.
Well, thank you very much.
Thank you. Where do we find you on the internet so we can follow you as you go through your life?
I do frequent Twitter a lot. I'm at TR Sohmers, basically TR, then my last name. I do have a website, trsohmers.com. If you find TR Sohmers anywhere, that's me. I believe I'm the only one. So.
Oh, cool. Thank you so much. This was the highlight, I think, for South by Southwest for me. And it's
thank you very much.
It's been a lot of highlights, including being in the front row at Jane's Addiction last night, which was great. But this gives you an idea of what we're doing here at the Rackspace Open Cloud Experience. We're seeing innovators and new entrepreneurs, people who are trying to change the world and come up with something new. And it's a lot of fun. We'll be back in a few minutes with a few more crazy people, including Chris Sod I just saw walk by. So come back in a few minutes and we'll start up another one. Thank you so much for joining us.
When Rackspace's live coverage from Austin continues, we'll show you the future in real time. Rackspace, backed by fanatical support, bringing you live coverage from South by Southwest daily. So good, it hurts.
The Open Cloud Experience.
I think in every technology category there are two standards, a closed proprietary standard and an open standard.